This question from section 1.8 is similar to project 5, where we need to write the equation of a line that passes through 2 points. We have 2 points here, and to write the equation of the line, we know that a line can have the form y equals mx plus b. So I need to identify both the slope m and the vertical intercept or y-intercept b. The first step is to determine the slope. And so we have a formula that we can use to find the slope. And so let's do that. So our y value is going to be equal to, it's the final y value, which is 8, minus the initial y value, which is negative 13, over the final x value, or x2, which is 5, minus the initial x value, which is negative 10. Okay, so we're going to compute that subtraction. I'm going to do a little bit of by hand simplification. So for example, I know that 8 minus negative 13, those two negatives are the same as an addition. So I can write this as 8 plus 13. And then I can write on the bottom those two negatives again as 5 plus 10. And I'm going to keep simplifying on this right here. So I've got my 8 plus 13, which is 21. And then my 5 plus 10, which is 15. And that fraction can be reduced. I know that I can divide both of those numbers by 3. 21 is 3 times 7, so I'm going to divide by 3, and I'm going to get 7. And 15 is 3 times 5, so if I divide by 3, I get 5. So we can reduce that fraction by dividing both top and bottom by 3, and I get 5. Okay. Now, just for a quick comparison, we can also use decimals to help us compute this. We don't have to work all by hand to compute the slope, but I do need to know the formula for slope so I can get my values in the appropriate places. So I'm going to switch my view over to here and just type in the same thing. If I start with a fraction, I know that I needed 8 minus negative 13. On the top of that, I'm going to zoom in for you real quick here. Here we go. And then I needed 5 minus negative 10 on the bottom. It comes out in decimal form, but I can switch it back into a fraction of 7/5. And 7/5 is the same fraction that we computed when we worked by hand and simplified and did the addition and reducing steps by hand. So it depends which is going to be more convenient for you. It's okay to use your technology to assist you to find that slope, but you still do need to know how to enter it. And that comes from the formula for slope, y2 minus y1 over x2 minus x1, or terminal minus initial for each of the output and input. Final output minus final input over final input minus initial input. All right. So now that we have the slope, we need to find the y-intercept. So again, I'm going to go back here, and I'm going to rewrite my equation. My equation was y equals mx plus b, right? And now I know m. So I'm going to replace m with, I'm just going to copy and paste this, replace m with 7/5. All right, I'm just going to go ahead and make that bigger. But I don't know b, so we need to discover b. So one more copy paste here, and I can take one of my ordered pairs. It doesn't matter which one. If there's one that has numbers that look nicer than the other, you can choose that one. I would probably go for this 5, 8, just because the numbers are positive, and I have a tendency to make fewer mistakes if I'm working with positive values, but you know, it doesn't matter. So I do know that in 5, 8, 8 is the output, it's the y value, and 5 is the input, it's the x value. So I'm going to plug them in that order, of course. The x value gets replaced with 5, the y value gets replaced with 8. You could have done the same thing with the other ordered pair for the x value and the y value. It doesn't matter which one. I can use this to solve for b. Right. So I need to compute 5 times 7/5. I know that the denominator 5 is going to cancel with this 5, so I know that this is going to come out as 7 over 1, or 7 plus b. And then I could subtract 7 from both sides. There, and that is going to get me 8 minus 7 is 1, and that's going to be equal to my b value. So back up here, I think I still have it copied actually. I can replace my b value with what I now know that it is equal to 1. Okay. Now, again, if you are not sure how to compute this portion of it, you could do that part of it in decimal. So you can say, I know I need to take 7/5 times my input of 5. So I could go over here and I could do that. 7/5 times 5. And I'm like, yep, it's 7. And then my next step would be 8 equals 7 plus b. So I can subtract 7 from both sides. We probably know that 8 minus 7 is 1, but I could still do the calculation if it was one that I was not familiar with. All right, so I get 1 for the b. All right, so that would be our answer. And if we go back into the MyMathLab page and we type that full equation, y equals 7, oops, I typed that wrong, 7/5, there we go, x plus 1. I can hit enter on it and it enjoys my answer. If I was doing this project style instead of MyMathLab style, just finishing off our details here, I could graph the two original ordered pairs. 5, 8 was one of them, and the other one was -10, -13. And my answering line was y equals 5/7 x. Yes, plus 1. Yes, plus 1, sorry. Okay, and so if I can zoom out enough, I may have gotten that ordered pair wrong. Let me look back. -10, -13, and 5, 8. Sorry, my daughter was distracting me. So I typed my slope upside down, actually. 7/5. And now it should be going through those two ordered pairs and get the label boxes checked right there. And so in the project, I would be all set.